Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Jeremy McCullough, a senior product engineer, and we're going to be discussing power and energy solutions. Hey, Jeremy, thanks for joining us today.
Hey, Cully.
So, we're going to be discussing power and energy solutions, kind of a newer thing to me, at least. It's very cool, very interesting, and we're very happy to have you here. You've given some talks on it, so hopefully we can demystify it. So,
Sure.
let's start way at the beginning. We have power and we have energy. What is the difference between power and energy?
Okay, so power is more of an instantaneous amount, and this is basically like how much your power you're using at any given time. So if you think of like, I don't know, a coffee maker or something, might be 1200 watts, or, a heated blanket is 100 watts or something like that. So that's how much power something takes and how much the electrical system has to be able to deliver. Energy is power over time. And so let's say that you have, we'll make it easy, we'll just say 1000 watts. You have a 1000 watt water heater. So that would be 1 kilowatt. And if you've, looked at your electrical bill, you notice that they probably get billed in kilowatt hours. And so what that means is you are operating something that draws 1000 watts for 1 hour. And so that's kind of a unit of energy. So it's basically power over a given amount of time. And so power affects basically like your supply, like so all of your breakers and everything, from the outlet all the way back to the power plant has to be able to deliver that. And then energy, what that affects is more like, how much your electric bill is. So the more energy you use, the longer you're using a given amount of power, the more your electric bill is going to end up being.
All right, so that's power, that's energy. Water heater, I think everyone can relate to that. But here at SUW Eurodrive, we're hanging out in the big industry, the industrial environments. How much do they care, or why do they care about the power versus energy, or these power and energy solutions?
Sure. So energy, I think, is probably like the more intuitive, example. Like, of course, they care about that because any industrial or commercial or really anybody, they have to pay an electric bill. If they use electricity, they have to pay electric bill. And that's mostly, and we'll talk about some reasons, cases where it's not. Mostly that's going to be based on the energy that you use. And so that's going to be in units of kilowatt hours and things like that. And so, of course, if you're a business, you want to minimize your costs, your electricity costs. And so the less energy you use, the less you pay. So there's that. And then power, where that becomes more relevant is, of course, like whenever you're building a plant, like you have to contact a utility company and you have to arrange for, service to your plant. And of course, the more power you need, the bigger, transformer you need, the bigger conductors, more copper, more breakers, more installation costs arise, as a result of that. And so power, it tends to be a one-time cost in the beginning because you have to make sure that you can supply the power for all the things you need to do in your plant. But we're starting to see cases where power is more relevant in terms of billing because, and you may have heard, or seen some examples like where, the electric companies, they're kind of struggling to meet demand, like in the summer. Everybody turns their air conditioning on in the middle of the day and, you're getting notices like, hey, consider turning down your thermostat. Or maybe in some cases, if you have a smart thermostat, it's doing it for you and saying, hey, your electric company says no. And the reason for that is, this goes back to kind of the demand, like at the power plant level. If you have, let's say that like on average, you have like a town or a city or something that's drawing, I don't know, like a megawatt or something on average. But on a hot summer day, everybody's running their air conditioning at once. Well, now you need 2 megawatts, for example. The power company, they have to maintain the capacity to deliver that 2 megawatts. So they can't just all of a sudden get that out of thin air. They have to have a power plant ready to go to be able to deliver that peak demand, because if they don't, what ends up happening is you have like, blackouts, the grid kind of goes down. And so that's a very bad thing. But if you think about the average case, if you only need 1 megawatt, it means you have a lot of like capacity that's sitting around underutilized. And so power companies are having to build these plants that are basically just kind of insurance against, that hot summer day when everybody's running, all of their electricity and their loads all at once. And it's very expensive for electric companies to do that because while it's sitting underutilized, they can't bill for that energy. They have all those maintenance costs like the the capital costs and everything associated with it. And so what we're starting to see in some cases, and it depends on your state, your utility provider, is that the power companies will institute what's called a demand charge. And so basically, let's say that you have a plant that draws, I don't know, 100 kilowatts on average, but then you have some process that takes, 500 kilowatts, and you only run that every so often, like you need to heat up like a really big furnace or something. Well, they'll charge you for the energy, of course, that you use over time, but they'll kind of impose almost like a sort of penalty saying, hey, we know you're only using this much energy, but because you have such a big difference between, what your average load is and your peak utilization, we have to charge you for that somehow because we're having to maintain that excessive capacity. And this really typically only happens at like really large scales. Like it's not like, at the household level or anything like that. But if you're, business as a factory, then maybe it's becoming relevant to you. And of course, you don't want to pay those extra fees. And so it makes sense that, you might try to, if it's at all possible, to minimize your peak demand as well. So it all it works hand in hand. There's different, scenarios where you might be concerned about one or the other, but that's just an example of, where it might become relevant to, a plant owner.
Yeah. And a lot of those bigger industries and plants are definitely folks that use SCW or other power transmission devices. So when we're talking about capacity or the power, I'm thinking immediately motors, drives, controls, automation. Is this where we're trying to alleviate some of that demand, or how we're trying to help our customers, where we're going to try and help you select based off this power and energy that you're consuming? Or how does the SCW product fit into the whole overarching idea of these power and energy demands of
Well,
these plants?
just kind of in general, like, motors, they make up a large portion of, typical plants like electricity consumption. And so you have, of course, you have whenever you size a motor, like it's typically by horsepower, and like, we'll just kind of keep the example, simple, and then horsepower directly corresponds to kilowatts. And so if you can get something that's more efficient, then that means your energy bill ends up being lower, because it's using less to do the same amount of work. And so, SCW, of course, we offer, efficient motors, different levels depending on, what motor type it is, what the relevant standards are, things like IE5 or, premium efficient and things like that. So, of course, we offer motors that are more efficient than, some that you could get, 10 years ago or something like that. So we do that as well. But that's for energy, of course, so that can help reduce your power bill. But to help with the power, the demand side, there's some other things that we can do, and we'll talk more about that like as everything goes on. But so whenever you buy a motor like of a given size, so you want something that's efficient, but then based on the power, you have to select a VFD based on that power rating typically. And then for that VFD, that affects the size of, the supply from your transformer, which affects like all the conductors in between and all the components, and then ultimately your transformer, and then the building supply, and all that sort of stuff adds together. And so if you can be, more smart about the way that you select those sort of things, and that's something that SCW, of course, can help with, then you can end up getting savings, on both sides, on both the power side, that's more installation and things, and then in energy, which is more your power bill. And also, if you are subject to peak demand, it can also, help with that as well.
So it sounds like SCW is definitely going to be a part of the power and energy consumption game, because as you said, electric motors are a very large percentage of energy consumption at our industrial plants. We're sizing the VFDs or the controls based off of the size motors we have generally. And you mentioned that SCW can help select or help guide our customers. I feel like that's going to be a pretty long conversation. So maybe we come back and talk about that next time.
Yeah, of course.
Is there anything else you want to talk about with power or energy, or is that a good jumping off point for the next couple of podcasts?
I think that's a good jumping off point. Just, simple overview, why it's relevant.
I like it. Well, we hope to see you soon, and we appreciate it, Jeremy.
Okay. Yep. Thank you.